All right, so in this video, we're going to be talking about humans and carbon. So first of all, why is carbon so important? So we hear a lot about it. We talk a lot about it. It's part of a lot of cycles. So why is it so important? Why is it this element in particular? So first of all, it is the basic building block of all living things. The reason for that is because it has 4 valence electrons. So it is equally happy in a covalent or in an ionic bond. So it'll bond with pretty much anything with those 4 valence electrons. So it bonds and builds with just about everything. It's absolutely necessary for providing energy for your body, in industry, for combustion in automobiles, and for generating energy. So basically any type of energy that we as humans use in our own bodies or out in the world relies on carbon. And then carbon is an essential component to the process of photosynthesis. So without photosynthesis, there's no life on Earth. So the fact that carbon is vital to photosynthesis means that carbon is vital to life on Earth. So carbon is a cycle. So good news, bad news with that is it is going to recycle itself. We aren't going to run out of it, but the trick is getting it to where it is most useful for keeping Earth stable. Right? So in our cycle, we're going to have carbon dioxide in the atmosphere, which is then going to be absorbed by that process of photosynthesis. And then when it's absorbed by photosynthesis, there's a couple ways it can go. So it can either be ingested by animals, either directly by animals or by the animals that then eat those animals. So our wolf eats a deer. That's how he gets his carbon. Or that cellular respiration process that emits carbon dioxide is just going to put it straight back into the atmosphere. So we're either going to have it cycle there, or it's going to be absorbed by photosynthesis, and then it's going to go into creatures. So when those creatures die, they're going to decompose, and after millions of years will turn into fossil fuels. Millions of years. They'll turn into fossil fuels. So we are just now getting most of our fossil fuels from the middle Carboniferous period, right there in our Paleozoic era. So after millions of years, they'll become fossil fuels. When we burn fossil fuels, that's combustion, and that puts carbon dioxide back into the atmosphere. So either things die, become fossil fuels, we burn them, and they go back out, or plants are going to recycle it as cellular respiration, or animals will recycle it as cellular respiration. So carbon exists in 3 places. So we think of them as sources of carbon, sinks, so carbon sinks, and carbon reservoirs. So sources are places or things that release carbon. So animals who either breathe or die, so decomposition or that respiration process. Volcanic eruptions are also going to release clouds of carbon dioxide, and burning of fossil fuels. So if you're burning something, if you're exhaling, or if you decompose, you're a source of carbon. So carbon sinks are going to be places or things that absorb carbon. So we're going to talk about these a lot in regards to climate change with our CO2 levels having increased. So carbon sinks are going to be plants and algae. Cold bodies of water, cold water traps gases more effectively. And then also landfills can be used as carbon sinks because they have materials that contain carbon. So it's not necessarily going to be a sink for carbon gas, but for the other carbon that gets put into the atmosphere, or that would otherwise get put into the atmosphere as things break down and decompose. And then reservoirs are going to be places where carbon is stored. So our sources release carbon, our sinks absorb carbon, and our reservoirs store carbon. So the carbon just hangs out there. So atmospheric carbon, that's just primarily carbon dioxide. Our oceans are primarily going to have dissolved carbon dioxide, so carbon dioxide that's trapped in the water there. And then rocks, volcanoes, and geothermal are going to have those mineral compounds, those mineral compositions of carbon. So this is really all about balance. So just like any other cycle, you don't want one side to be heavier than the other. So the trick with carbon dioxide as a greenhouse gas and its role in climate change is the fact that it's no longer in balance. So the carbon that's being put into the atmosphere isn't being absorbed and put into the earth as fossil fuel at the same rate as it's being consumed and used and released. So we're releasing more carbon dioxide than we're able to absorb. And that's where this whole thing gets thrown off. So when there's an imbalance between these two, when you have more sources than you have sinks, then Earth is going to get warmer because you're going to have more of that abundant greenhouse gas in the atmosphere. So if we go back to our carbon cycle for a second, we have a lot more combustion happening than we do photosynthesis or even just carbon being eaten by organisms. So we have a lot more carbon here than we should. And finally, how humans increase atmospheric carbon. So how did this imbalance first occur, right? And the big one is burning fossil fuels for energy, which includes using engines. So anytime you're burning anything to get energy, and we're going to talk more about that next week with how burning stuff actually creates energy, that's when you're going to see any kind of carbon get released into the atmosphere. Anytime you've got that combustion, you've got that burning, you're releasing carbon dioxide. We've got deforestation, so we're cutting down those trees and other photosynthetic plants that would absorb that atmospheric carbon otherwise. So we have fewer things to absorb the increased carbon we're putting into our atmosphere. And then agriculture can also be an increased source of carbon. One, because you do tend to level the land. So we do tend to cut down any trees, grass, shrubs, whatever that are there to get that flat cropland. And then also livestock. So the livestock industry, so growing and preparing livestock for people to eat is a huge use of carbon. And then just other everyday activities. So little things that we do that we don't even think about are going to help, or are going to not help, but are going to increase the amount of carbon we have in our atmosphere.